Good afternoon, everyone, and thank you for attending this webinar brought to you by the Streaming Video Alliance called Transitioning Video Delivery to the Cloud Best Practices. We have an absolutely fantastic panel of presenters lined up from Beamr and Edgeware and Espial and Verimatrix and Concurrent. Lots of guys with lots of experience on what it means to sort of deliver video from the cloud and use cloud technologies as part of the video delivery ecosystem. My name is Jason Tebow. I am the Executive Director of the Streaming Video Alliance. If you don't know about our organization, we are like a standards body similar to IETF and CTA. We focus on building best practices and guidelines and functional requirements, specifications to help solve critical challenges in the video streaming ecosystem and ultimately to help provide a better viewer experience for online video. All right, so a little bit of housekeeping. This is about a 60-minute webinar. We'll try to end with some questions. We may break in the middle as well to ask questions for the audience. If you do have them, you'll see a little questions link in your GoToWebinar panel. You can just ask whatever questions you want, and I'll try to get those assigned to people and get them answered. If we don't answer them all by the end of the webinar, we'll try to reach out to you after and get you an answer. And then this webinar will also be recorded, so we will have an on-demand version available probably later this afternoon. It'll be on the Streaming Video Alliance website at streamingvideoalliance.org. Emails will go out to everybody, so you'll be able to pass that around to all of your colleagues as well. All right, with that out of the way, let's get to some introductions, and let's start off with Dror Gill from Beamr.
Hi, I'm Dror Gill. I'm CTO and VP Product at Beamr. Beamr offers solutions for video encoding and optimization. The solutions are based on technology that's been in development for many years, technology that enables us to encode the video at very low bit rates, but still at very high quality. And the technology has until now over 40 granted patents. We offer this technology in several ways. One of them is SDKs, which are encoders and decoders for AVC and HEVC. And we also have a full transcoder product that starts from a mezzanine file and ends up in a fully packaged stream that is ready for delivery. All of our solutions can be deployed both on-premise and in the cloud. And we also have optimization solution that take existing files and reduce their bit rate by up to 50% without affecting the quality. And this enables better streaming of video over the internet.
Fantastic. Thank you, Dror. Our next panelist is Raji Sankaran from Concurrent. Raji, can you sort of give a brief introduction of yourself? And I think he's on mute, so. All right, let's move on. Oh, there's Raji. Raji, how you doing?
Hey, I'm doing good. Sorry for joining late. I was engrossed in something else now. Yeah, I'm Raji Sankaran, and I'm head of Concurrent Technologies. We provide software for the video servers. The Edge, our most popular servers are the Edge and the Origin server, which uses the transcoder. Origin uses transcoder, but we use transcoder from iPoji. And I work on the video analytics team. And we are trying to analyze the traffic, the log files, so that we can give more recommendations to the customers. Yeah, that's about it.
Yeah, fantastic. Thank you, Raji. All right, our next panelist is Johan Bolin from Edgeware.
Hello, thank you. My name is Johan Bolin, and I am the VP of Product at Edgeware. And Edgeware, we provide products for building CDNs and Origin solutions. And we have been doing so for quite a while. We started up in 2004, and back then, needless to say, it was on-prem. But we have since I would say 2012 adopted different virtualization technologies, and quite lately, basically last year, we started to work with containers and orchestration tools, and can now deploy a significant part of our portfolio in both private and public clouds. And we do that for both live and VOD service, and it's especially the live video that is to some extent challenging. So I will get back to that later. That's, I think it.
Anything else, Johan?
No, not for now. Thank you.
Okay, great. Our next panelist is Mick McCluskey from Espial.
Hey guys, it's Mick McCluskey. I'm VP Product Management at Espial. At Espial, we have a TV as a service business called Elevate. TV as a service essentially is a service we offer primarily to pay TV operators. The service includes clients for users to access service, the subscriber management functions, media processing functions, including encode, origin, and distribution functions. As part of that, we have 100% of the subscriber management functions is always on cloud. We offer two options for media processing, either on cloud or on-prem, and I'm sure we'll come into the reasons for those choices as we go through the webinar. Today, we offer service to over 40 operators, serving millions of devices, including set-top boxes and consumer-owned devices. And a lot of what we are seeing in the industry at the moment is a very high interest in migration towards IP and OTT technologies for delivery of services, particularly targeting unserved or underserved segments. Thank you.
Fantastic. Thanks, Mick. And our last panelist is Peterka from Verimatrix.
Hello, I'm Peterka. I'm the CTO of Verimatrix. Verimatrix is a content protection company. We provide conditional access systems, digital rights management systems, watermarking, and data analytics for over 900 operators around the world. I think we are in 110 countries. As you can imagine, most of our existing customers are on-prem. That's where most video and pay TV has been historically happening. But we see a strong trend of migrating certain aspects of the video delivery pipeline into the cloud. We started migrating the OTT deployments to the cloud, and our data analytics and data collection system called Perspective is also pretty much exclusively in the cloud. And eventually, we believe we'll migrate all of our systems and support to the cloud. Thank you. JT, did we lose you?
Oh, sorry about that. I was talking to the phone on mute. So yeah, quick note to the panelists: if you've got your computer volume turned up, you want to mute that, especially if you're on the line on a phone. So we're getting, we want to avoid getting an echo. All right, so let's jump into the questions. Now, obviously, the companies we have represented here today really span the delivery ecosystem, right? It's lots of elements and components within the workflow. Some of these are full solutions, and so obviously lots of reflection of technologies as really broadcast television kind of transitions, to streaming video. And there's lots of contention in that statement, but I'll leave it at that. So my first question I have for you guys is, are all of the technologies associated with traditional broadcast moving to the cloud, right? I mean, obviously we've got companies that are containerizing things and putting things in the cloud. And, does that include everything, or are there still some technologies that are remaining on-prem? And then sort of to add to that question, sort of which video delivery technologies are, I guess, what we could term cloud ready, and which aren't? And I'm just going to open it up to sort of all you guys right now, and just somebody say, "I got the first answer," and let's go.
I got the first answer, Jason. So this is Mick McCluskey from Espial, if that's okay. So look, I guess each of us will probably have our own perspective, and I'll speak only from the context that I have. But what I would say is I have seen lots and lots of traditional cable technologies, DVB, RTSP, and even IP multicast technologies not moving to cloud. Mostly what we see for moving to cloud are adaptive bitrate technologies being used for media streaming. In addition to that, in the business we operate in, as I'd mentioned in my introduction, we see things like subscriber management functions, the control of the video services delivery 100% in the cloud, and general acceptance for the customers of our business that makes a lot of sense and gives them significant benefits. I would say in our business, however, that media processing meaning the encode, the origin, and the distribution of content, including NDVR and timeshift functions, that's still separated a little bit. Some operators, for a variety of reasons that, again, we'll probably touch on in other questions, but things like security, control, issues of redundancy. Media processing is sometimes on the cloud and sometimes on-prem. And those decisions are still being made. And then finally, I would say when it comes to media processing, one thing that is often on-prem is edge caching for operators who have their own footprint and wish to distribute it. It is often much more cost-effective for those guys to have edge caches as opposed to public CDNs. Different, obviously, for operators who wish to distribute more broadly across subscribers outside of footprint. So to summarize, I would say I do not see traditional cable or even IP multicast technologies in my space moving to cloud. It's much more unicast ABR. That subscriber management is almost always on cloud. Media processing is half and half. And parts of the media processing chain, particularly the edge caching, typically falling on-prem.
Hey, Mick, this is Petr. I partially agree, partially disagree. Yes, it is very clear that the OTT streaming delivery of content is much easier to run from the cloud for a couple of reasons. There is fairly little, if any, dependency on hardware, and there is very often no legacy investment that the operator made. But on the other hand, we see even traditional IPTV operators who are migrating maybe not 100% of their operation, but maybe 90% of their operation to the cloud. And yes, there are some fundamental components that are still staying on the ground or on-prem, such as the muxes and the multicast streaming component. Or if you are a DVB satellite operator, you always have the uplink, the satellite uplink on the ground. There's also, if the operator made historically investment, let's say in computing technologies, right? They have hardware encoders. They need to amortize that investment, and so they keep that on-prem, while as they transition to, let's say, new encoding technology such as HEVC, it doesn't make sense for them to buy hardware encoders, and they do encoding in the cloud. And lastly, when we added data analytics part of our product, that was exclusively deployed in the cloud, again, because there was really no legacy, and the cloud is much more suitable for collecting and processing large amounts of data.
Anybody else have anything to add?
I could maybe I could comment. Johan Bolin here from Edgeware. We are very much in the distribution space, which is where cloud might not always make sense. Still, I would say that the short answer to this question is that yes, everything is going up to the cloud. not necessarily that everything is being migrated, but eventually some technologies will simply be like replaced with web and HTTP-based technologies, and as a part of that, I mean, all functions are going to the cloud, but that might not mean that all technologies are going to the cloud. I mean, we have been struggling a bit with getting multicast to work in the cloud as an example, and that is not very easy. So some technologies, if you want to continue to do it, I think it's better to do that on-prem. From a more conceptual perspective, I would argue that the piece that might not fit in the cloud from an architecture perspective is maybe the CDN caches, for a couple of reasons. One is that you want to have this as close to the user as possible, and the other is that these caches are pretty much storing a lot of content, right? And storage actually is one part of the cloud that doesn't always make a lot of sense, because I mean, X number of petabytes in the cloud cost as much to invest in as X number of petabytes on-prem. What might change this is recent kind of technologies for network virtualization and so on. And I think 5G, as one example, will change this a bit, because that means that you can start deploy virtualized software out in the network. Whether this is cloud or not is of course not a discussion, but using similar technologies also in the network, I think, will happen, but later than the rest.
Yeah, that makes sense. I really like actually that comment you made about thinking it in terms of functions versus technologies. That makes a lot of sense, because obviously as broadcast moves to IP, those, operators, broadcasters, content distributors are going to look for ways to figure out, how do I leverage these cloud technologies, which can save me, lots of money versus, hardware and equipment on-prem, to do the function I need it to do. And so that's where, really innovative technology companies, and folks like you come in, and you sort of figure out, like, how do we get IP multicast? How do we get multicast ABR to work into the cloud? Which, as Johan said, that's a really tough thing to do. All right, so let's move on to another question. So, one of the things I've been looking at, and I've been in the space now for, probably about 15 plus years. And I've seen sort of various cloud technologies to deliver streaming video, right? They've been around for a little while. And obviously they've matured and they've gotten better. So my question to all of you is, how have those cloud technologies to deliver streaming video changed over the past few years that make them even more attractive to companies to use today?
I can answer that. I can start at least. This is Dror Gill from Beamr. I think one of the changes in the cloud market is that if you look a few years back, a cloud offered you basically computing and storage services, very basic services that could work across any application, sometimes maybe a database, but that's it. And if you wanted to do any video processing in the cloud, you would have to use a third-party service, such as encoding.com or Zencoder, if you want to do video encoding. But now, in the last few years, all of the major cloud providers have acquired or developed their own technology and are offering their own services for video encoding and delivery. Microsoft, for example, is offering Azure Media Services. Amazon acquired Elemental, and they're offering AWS Media Services. And Google acquired Envato, and they also offer their own transcoding and streaming services. So actually today, when you go to a cloud, you can get not only basic infrastructure on which you need to run your own tools, but you can also get the full suite of media transcoding and delivery services from the cloud provider itself. And then you don't have to rely on any third parties, and you go to a single source for all of your cloud needs. And I think the second trend is that the infrastructure of the internet has improved significantly. And now customers can much more easily move those large mezzanine files, their source files, between their own data centers to the cloud. And even in live situation, they can stream high bitrate streams to the cloud that have very high reliability and reasonably low delay. And I think this makes the cloud much more viable today for live streaming applications. Beamr offers a live transcoding software in the cloud that can do 4K P60 of HEVC with 10 layers on a single server. And today, when our customers want to deploy this in the cloud, they can very reliably deliver to us a mezzanine stream of 100 megabits. And they can be assured that no packets will drop and will be able to receive it in full and process it. So I think the infrastructure improvement is another trend. And the third one, and I think that's the most important one, is the move to containers. Being able to deploy your video processing elements as virtualized containers, whether that's video transcoding, the packaging, the DRM, it means that all your video workflow can be deployed very easily. You don't need to do any installations. Those containers are self-contained and have everything you need. And you can easily scale them across multiple servers. And also you can use them, the same containers, both on-premise and in the cloud. So you can have a hybrid strategy for video processing. And we're seeing in the last 12 to 18 months Docker containers everywhere. We're offering our solutions for video optimization and transcoding as containers. And I think this is a very important trend that is enabling video delivery on the cloud and hybrid at a much larger scale than before.
Dror, that's just better. I think you covered it pretty well. The only thing I would add to it is I think maturity of the underlying security model, where if you have a strong identity and access control management, if you have strong mutual authentication between endpoints, if you are connecting multiple components, even multiple services within the cloud, you have mutual authentication between them. And then if you have key management services or even hardware security modules that are available in the cloud that allow you to encrypt data both at rest as well as in motion, this kind of underlying security infrastructure and maturity of that, I think gives operators sort of confidence that moving their operation from on-prem to the cloud doesn't add additional security risk.
Right. I would even say that the cloud servers are secured at a higher level than most companies can afford to secure their own servers on premise.
Yeah, I agree.
On a slightly related topic, I think building on the points that both of you guys have made, I think generally I would say that the cost and economics of cloud-based deployments have changed very significantly over the last number of years, meaning that it is much more within the reach, much more economically viable for operators to deploy. Building on the containerization strategy, things like auto-scaling allows for functions that scale up and down with demand to be much more cost efficiently treated, and things like redundancy models, including geo-redundancy, to be much more efficiently handled than with on-prem solutions. However, I would also say that there remain some structural challenges for especially smaller operators to leverage cloud, particularly around the areas of encode costs, which typically do not scale with demand or with meaning consumer demand, and also storage costs associated with functions like time shift TV. So I would say that a lot of the evolution I've seen has been around the cost and economics, and that's been generally a big improvement, but there remain some areas where that still can be challenging for certain operators.
I think I would like to comment the previous speakers a bit, because I think our perspective on this is, or what we have learned recently, what we have figured out is that maybe it's not the cost savings that is the more important question to ask yourself. The cost for infrastructure, you could argue if you save that or don't by using the cloud instead of on-prem. I think the big savings you have by using cloud technologies, and this has also been facilitated now by containerization, I mean standardized containers, is speed of innovation and time to market, together with actually reliability. Because that means that you can typically develop in the production environment, which you have never been able to do before. So you have one environment that do both production but also development, meaning that you can deploy new services and new features more or less every day. And the cost for missing market window is often much higher than the cost for the infrastructure you're running it on. And I think that here is where containers and so on have made a big difference, because that means that you can use not only tools that is designed for video, but actually tools that are designed to orchestrate containers with, to get the flexibility and the reliability, facilitating that kind of work method where you develop in your production environment. So that is something that you should not forget about when comparing cloud with on-prem.
Yeah, I think it definitely goes without saying that the cloud has lots of advantages, to organizations looking to distribute video, in a streaming format, and that those advantages have improved over the years, right? We've seen lots of technologies get better, lots of systems improve, the containerization, all that stuff, microservices, the ability to develop and iterate quickly. The cloud seems like sort of the natural place to migrate, as broadcasters shift their traditional delivery to IP and streaming. With that said, though, there are a lot of cloud providers now. I mean, throw a stone and you're hitting 10 of them. What should a video distributor, whether it's a traditional broadcaster or a pure play OTT company, what should they look for in a cloud provider for their streaming technology? Are there, what are some of those best practices? Like, hey, it should all be about cost, or hey, it should be about scalability, or hey, it should be about redundancy. What are the things that they should keep in mind?
So maybe I could take a stab at that, Jason. And again, I think it really depends on who they are and where their starting point is. The reason I say who they are and what their starting point is, if they've got a large development team and very competent engineers skilled in cloud technologies, then I think they're probably looking for more cost efficiency and better development platforms. If, on the other hand, they're essentially looking to do more of an outsource or seek to, sort of put stuff on the cloud but require someone else to do the work on their behalf, then in that case, they're going to have to look for, who are those parties, which cloud are they on, what are the characteristics of that cloud. So, for example, public clouds, we've talked a little bit about, things like containerization and auto scaling and security functions. Private clouds, and I know cloud is a much overused term. I have certainly come across people talking about cloud deployments where they are actually talking about servers in private data centers. So you need to think about what is it and how scalable is it and how cost effective is it. If you are also outsourcing some of those functions, you need to think about what's the track record of delivery. You also need to think about what's included or not included. So is the infrastructure included or not? Are the 24/7 monitoring and operations included or not? Are the services to update, upgrade included or not? Have the implementation that is being undertaken got proper containerization and leveraging those functions for things like auto scaling? Are you able to have hitless changes and updates and upgrades without impacting your service? What's the security model? I think Petr touched on earlier in the presentation about what the security model is, and I certainly believe that cloud can have a much better security model than many operators are capable of building. But those are questions you really need to undertake. And then finally, you need to think about things like what's the continuous innovation model? If I get on the cloud, how do I continue to innovate, develop, and evolve my services based on the cloud? So those are some of the considerations I think are important for anybody starting to look at cloud deployment for video.
I would add to it that yes, the security components are important. Having the right building blocks to secure your data and your operation, but also the monitoring, reporting, and alerting systems need to be there. And last but not least is compliance with industry standards and regulations. For instance, MPAA has a set of best practices and guidelines that operators need to comply with. If you are operating in Europe or have European customers, GDPR and other components are important to comply with.
I could perhaps, first of all, good point, Petr. I think that the check if the storage is MPAA cleared is a good thing to start with, because if you build your entire solution, then you realize the day before launch that you haven't clarified your storage, and that will be a challenging task to do in a short time. But then a couple of other concrete things. Since I'm on the distribution side, so first, location. If you're using a public cloud, you have public clouds in different locations, and if you want to get your content out of that cloud, it might be a good idea to check first where the cloud is, but then also what kind of direct connect options you have with that, because just getting it out as cloud egress might be very expensive. So you might want to consider some kind of leased line to that cloud to get it out on the different ISP networks. Another thing that we have kind of touched on is it might be tempting to use a lot of tools inside the cloud. Like AWS as an example, they have a lot of very good tools to use. The danger if you do that is that then you become dependent on that cloud platform. So the advantage with using like Docker containers or something standardized and avoid using tools that are uniquely designed for a specific cloud environment means that you can actually migrate to another cloud if you would need. And I think last but not least is also just check the price models, because our experience is that especially the egress side of cloud could be very expensive, and there are different ways to lower that. So that is something you should check. One other thing just to mention fourth then is different cloud platforms seems to have different levels of packet losses inside the cloud. And this is something that is important, especially if you want to do some live service on that cloud. So test and check what packet losses you have on different cloud platforms before starting to develop too much on that cloud platform. So that's 4 small things to look into.
It sounds like there's a lot to consider, which is understandable and acceptable. I mean, and that's really sort of what I hoped would come out, as part of this webinar, to help people understand what are some of the things I need to think about, when I move or start or create a video delivery service that employs, cloud technologies. One of the things though that I guess the video space is really sort of concerned about lately is live streaming, right? So everyone is jumping on the live bandwagon. We're seeing more movement of traditional linear broadcasts, general channels on an EPG to streaming video. And so as live linear moves to streaming, the big issue that people seem to have is around latency. And we've seen a lot of companies come out with what they quote unquote call zero latency or real-time streaming. Some of these are using WebRTC, some of them are using other technologies. But, obviously, with the cloud, there might be additional influences to latency, right? So there, do the cloud technologies, does the use of the cloud, does that impact video delivery latency as it relates to live? And what are the ways, or some of the ways, that video distributors can mitigate that latency?
I think, yeah, I can give it a...
Go ahead. I was just going to call your name.
Okay, I could call. First of all, it impacts a little. I mean, cloud as a platform impacts a little, but not too much. So it's more what technology choices you have for streaming and how you configure your CDN and clients and so on, rather than what platform you use. I mentioned earlier that you might have bigger packet losses in a public cloud compared to what you would have on-prem, and that impacts latency a little, because you typically need to turn up your UDP buffers a bit, but these latencies are marginal in the overall latency dimension. So to give just a figure, I think we have adopting just standard protocols, not even any shunt technologies, just standard segmented dash and HLS. We can deliver live from the cloud and via CDN in latency that spans between 5 and 8 seconds from the contribution encoder to the actual video playing on the screen, which is, I think, quite okay compared with also on-prem solutions. So my experience is that the cloud platform as such doesn't add much.
Okay, anybody else have anything to add to that? Okay, so here's kind of a different question. Obviously, one of the things that's great about on-prem stuff, and to be honest, about hardware, is you can buy multiple boxes. so it's very easy to create redundancy, especially when you talk about like encoding, right? So you can have 2 encoders, one goes down, you still have the other one that's working the content. But how does that work in the cloud? So for example, AWS has had some notable outages, right? So AWS goes down. So let's say there's a DNS misconfiguration, and oops, your cloud is unreachable. How do video distributors deal with this? What are, again, some of the best practices for building in redundancy to cloud-based delivery?
I think that on-premise you can buy more boxes, that's right, but it's not that easy. You have to know how many you need to buy, how many events you're going to have, and usually a lot of those boxes just sit around unused most of the time, and when you have events, they're actually utilized. In the cloud, the redundancy is built in between all of the different servers that you use. You can deploy 2 servers for redundancy, you can deploy 3 or 4, whatever number you want, and if one of them fails, then you can fail over to another one. And then you have other levels of redundancy. You can deploy your service on 2 different regions, for example, and this again significantly lowers the chances that both of them will experience issues at the same time, because they're completely separated infrastructure geographically and also on the level of the network. So that can help. If you are really worried, I mean, all this concept of redundancy is really risk management. What's the risk you're willing to take? What are the chances that you're trying to work against, and how much do you want to invest in making sure that whatever happens, around the world, your broadcast will continue. So if you want to be even to mitigate even more risks, you can have a dual cloud strategy where the same stream is going to two different clouds, and then you can switch between them. So in contrast to on-premise, when all you have is two different servers, but then what if the power goes out in your broadcast center? On the cloud, you have many more options and level of redundancy that you can deploy to ensure that your service will be uninterrupted.
Yeah, I would just add to what Dror has said and say that not only are you able to have many more options, but the cost effectiveness of those options is usually significantly more attractive on cloud than on-prem, because whatever option or scenario or multi-layered strategy you decide for on-prem, essentially you need to purchase all of the equipment necessary to achieve that full redundancy, so that if you have multiple sites, you need full replication at both sites. Cloud allows for models where you can turn servers up on demand, so that your actual costs of having redundant solutions and having multiple layers of redundancy can be much reduced, and that in turn may permit you to enter into redundancy models on cloud that might be cost prohibitive were you to try to replicate those with on-prem solutions.
I think I would like to add one thing on the redundancy, because this is something that we quite lately have worked quite a bit on. And the good thing with cloud is exactly as Dror and Mick have mentioned, that you have basically unlimited capacity, and having a lot of muscle mass to use if you need is a very good way to get redundancy and so on. But the challenge with cloud is kind of a challenge you had before as well, but we experience that this is slightly more challenging on the cloud, and that is synchronization. So it's not really redundancy as such, it's more if you want to have a seamless redundancy, that you can do a switch over from one data center or from one POP to another, or ultimately from one cloud platform to the other, without noticing any glitches in the video stream. That is definitely possible, but it takes some. I mean, you need to think a bit how to do that, to get that to work. I could elaborate for hours on that, but by the way, but that is one thing that we have learned that is a bit challenging.
All right. I mean, so redundancy does exist, and you know, I'll be honest, I knew it did. And I know that there are services out there that allow deployment of containers across multiple cloud providers. So they sort of call it a, you know, meta cloud manager. I know those are, you know, really sort of starting to come online. Some have been around for a little bit, but they're getting very intelligent. You know, obviously, lots of data needs to come into the decisions about when to switch, you know, operations between cloud providers that are part of a multi-cloud, you know, architecture or, you know, or deployment. I mean, that's really important, and that's starting to happen as well. So it's, I think that's, you know, you guys, those are some great answers. I mean, that's, you know, there is redundancy. And to Mick's point, it's probably a heck of a lot cheaper to build in redundancy into the cloud than it is to do it on-prem. All right, you know, one of the things we kind of touched on earlier was this concept of security in the cloud, right? So lots of organizations, you know, they're experimenting with cloud technologies, and they're still concerned about, you know, security, right? How do I keep my things secure? And now with this concept of, you know, elements within the workflow, you know, moving into or existing in the cloud, what are some of the security considerations that video distributors need to address in order to sort of keep everyone happy?
JT, let me jump into this. As a security vendor, obviously we worry about this a lot. There are at least two dimensions to this. One is what people call security in the cloud, and that's how you need to design your application, your service. And then there's the security of the cloud, and this is what your cloud provider provides to you. On that, I think somebody already mentioned it today on this in this discussion, that in my experience, your public cloud providers have much better physical security. They probably have much better IT staff. They have much better processes for managing the security of the cloud. So I think that's a benefit for most people. The security in the cloud and how you design your service and your application, that has several different components. We already talked about strong identity management and access control. That must be part of the infrastructure that you use. You don't want to be designing this from scratch. You need to be able to enable traceability. You need to be looking at what's happening in the cloud. You need to be able to monitor log files, real-time transactions. You have to have a threat detection and an alerting mechanism built into the infrastructure. When you are architecting your system, you need to think about security in different layers, or as people say, defense in depth. Typically, you build at least a 4-layer architecture where you have, on the outside facing, you have a threat protection layer. This is to prevent, let's say, DDoS attacks. Then you have a presentation layer. That's the part that end users see, and you need to isolate it from your actual application layer. That's where you're processing your algorithms and everything else is running. And then probably the deepest in the architecture, you have your data layer, and you need to worry about how you protect your data. We talked about securing your data at rest. So when it's stored in a database or some kind of a data lake, you have to have access to secure key management systems, the ability to encrypt that data and give rights only to individual applications or individual users to access subset of that data. The same thing is for data in transit. You need to have support for VPNs. You need to have a support for mutual authentication and TLS. Some cloud providers provide you with a certificate management capabilities. So that's all important in protecting your data. And then we already talked about the secure backups, reliability, recovery, especially disaster recovery, and then incident response. There is no system that is completely immune to breaches or security incidents. So you have to build a mechanism for an incident response, which includes first detection that something happened. You need to have enough forensic data and find out as quickly as possible what actually happened. And then you need to fix the problem, and then you communicate it to your affected customers. So this was probably a mouthful, but these are all the things that you need to address. And the more tools that come with the cloud infrastructure that help you with this, the easier the job is.
Just a couple of thoughts to build on that exceptionally comprehensive response from Petr. One was earlier we asked the question, or Jason, you asked the question, what to look for in cloud solutions. And I think, really the sort of structure, the sort of architecture, the sort of approach that Petr has outlined is definitely something you want to see. I think it's in some ways it's easy to get software to run on the cloud because you just take software and you make it run on cloud. It's actually not sufficient. You need to think about what are the cloud capabilities and how do I structure that software into containers and into architectures that support functions like security. So definitely you need to architect some of those elements in right from the bottom. The last thing I wanted to touch on here, and I think we've also touched on, is in the area of security, and that's really around privacy and privacy of data. And I think one of the other speakers had mentioned GDPR, but also the Canadian equivalent, the Californian equivalent of consumer protection of consumer data. And that's also becoming increasingly important across many different geographies, that becomes an explicit consideration as we look at our security strategy.
Anybody else want to add to that? I mean, that's a great answer by Petr and an equally great follow-on by Mick. I mean, it's, you know, clearly there's something to be said here about security considerations. All right, so we've got about 8 minutes left. I just want to remind the audience that if you do have a question, please submit it in the question panel. We did have one that I had to reach back out to the person for some more clarification, but I haven't received that clarification yet, so I can't throw that question out at the panelists. So until then, let's ask another question here. Now, you know, I get maybe this is an obvious question, but I'm going to argue that it's not. Lots of people, as we migrate, you know, video distribution and the video delivery workflow to the cloud, doesn't, you know, necessarily have to be OTT, but using the cloud infrastructure to do a lot of that heavy lifting and delivery, you know, people, I think, assume that that's a massive improvement to what exists today in the traditional distribution of video. And, you know, I think it deserves an answer. Like, so how does the cloud improve the video delivery workflow? And at the same time, how does it complicate it?
So I think we talked about a lot of advantages to the cloud, the security, the scalability, the cost, obviously. And also we mentioned that it's very easy to try out new things. I think, for example, if you want to try something new on your video workflow, try some video search, try audio transcriptions or automatic translations or any other machine learning task. In general, there are many tools available on the cloud that you can very easily use, and then, you know, access them and try them out. And if you're interested, you can plug them into your workflow. So there's a lot of important advantages. On the negative side, I think if you rely on a single cloud, the control can be an issue, because if there are any disruptions to the service and you want to fix them, you're actually dependent on your cloud provider. If you have some issues, to give you the right priority in fixing your issues, and you actually have less control of how and when those issues are investigated and fixed. So you do lose some control over having your own IT department and on-premise server farm when you move to the cloud.
Yeah, I think the freedom to try things out is really powerful. We had one customer who was trying to experiment with kind of a new type of an OTT service. They had a niche content, but they didn't know whether this was going to fly or not. Is it going to be popular? Are they going to make money or not? But they didn't want to invest in a lot of hardware, so it was, you know, from our point of view, pretty obvious to try and deploy this in the cloud. They had no large capital investment up front. They set themselves, they set a rule that, you know, within 6 months they will reevaluate. And then they tried things out and had the freedom to shut the service down without now being stuck with a lot of hardware that they had to buy. So this ability to experiment with a new service without risking a lot of capital investment is very powerful to me.
Yeah, if I could add to, first of all, I very much agree. I think the flexibility and the low cost to start up things is very powerful. One thing that it means, though, is that it's maybe a bigger change in culture and ways of working, both operating this but also developing products for the cloud. Maybe that's bigger than the actual result of what's coming in, what's going in and what's coming out, if you will. And first of all, when you build things on-prem, you have a tendency to build nodes that you want to build as robust as possible as nodes. And then you have a platform that is also as robust as possible to run that application on. When you do things for the cloud, you need to assume that microservices will crash all the time. So instead of focusing on building the actual node or the application robust and reliable, you need to build a solution robust and reliable, meaning that you need to have the mechanism so on to start up processes again automatically, etc., etc. And that means both the design thing, how you design your entire solution and the application. It also means that the guys operating this typically needs to be more like developers rather than just operators. So it's not only about configuring stuff anymore, it's actually about writing some code. And that is maybe something to keep in mind when engaging this.
Absolutely. All right. So we have a couple minutes left. We did get a clarification on the question. So I now have a question I can pose to you guys. I think there's probably maybe, Johan, maybe you can jump in first on this. But the question is, what kinds of egress fees can a company expect when migrating from on-prem transcoding to cloud-based transcoding? And how does a leased line impact egress?
Yep. The actual cost varies between different cloud vendors and different geographical location. So in Sweden, there will be one price. If you buy it from Germany, there will be another. And in the US, most likely a third. And the typical cloud price for the egress data is that you pay for the volume that you have egressed from the cloud. And this cost can be very steep. I would argue if you deploy your solution in the cloud and you just use the standard egress fees, the egress fees will represent 90% of your costs for that solution, and they will be very high. So doing this for a large number of linear TV channels might not be super good. So the first thing you need to do is to really optimize your CDN. So you need to have a CDN that provides a super high cache hit ratio that is kind of below the cloud, if you will. Typically higher than what Akamai and Level 3 and so on would offer. So I think a common setup is that you deploy some kind of origin caches on-prem in between the cloud and the CDN. Could also comment, by the way, that since the egress from the cloud is very expensive, you should avoid building solutions where you put content in and out of the cloud. Try to get the content in the cloud once and then keep it in the cloud for all the processing before getting it out. So combining on-prem and in-cloud solutions so that you send the content forth and back is not a very good idea. And what you do if you do a leased line instead. So I would argue at least all bigger public cloud providers typically work with ISPs so that they offer what they call direct connect. And direct connect means that you can actually lease a fiber or a line, let's say a 1 gigabit per second line or a 10 gigabit per second line from the cloud to a particular POP, to a point of presence. And what you do then is that you kind of convert the price model from being a pure volume one to a model where the lion's share of the price is just a fixed fee per month based on the bandwidth. So there's one price per gigabit per second pretty much that you have leased. And then there's a small fee based on the volume. So you kind of trade volume to a committed capacity instead. And this means that if you have a decent CDN, maybe augmented with some origin caches, so that you can bring down the cache misses, if you will, so the traffic from the cloud a lot, then you can actually get the quite economically feasible setup. But instead, the leased lines typically are sold with 1 year or even multi-year commitments. So you lose some of the financial flexibility with the cloud. So I don't know if that answered the question, but I think that was at least some about it.
Jason, did we lose you?
Sorry, I'm on mute, talking to mute. That was a great question. It was a great answer. The question asker said, thank you. That was very helpful. I just want to say I appreciate all of the panelists today for taking the time to join this discussion, and all the attendees for taking the time out of their schedule to listen. Again, I will have this posted on the Streaming Video Alliance website later this afternoon, and the on-demand version can then be passed around to whomever needs to or wants to watch. Anyway, thank you again very much. I hope everyone has a wonderful rest of their day and week, and we'll be back again with another webinar soon. Take care, everybody.
Thank you.
Thank you.
Bye, everybody.
Bye.